Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is Z test, and we know that we are in the fourth block, which much focus on testing of hypothesis or the probability testing, and under the ambit of this we are what we have discussed in our previous session, that was more focusing on testing of hypothesis. Now we are much more going and talking about Z test. So this is one of the prominent tests which is quite useful as far as the testing is concerned. A Z test is a statistical test to determine whether two population means are different and when the variance are known and the sample size is large. So it can be used to test hypothesis in which the Z test follows a normal distribution. A Z statistics or Z score is a number representing the result from the Z test. So if we talk about the formula, the Z test formula is x bar minus mu upon sigma upon square root of n. And Z test is a statistical procedure used to test an alternative hypothesis against a null hypothesis. Z test is any statistical hypothesis used to determine whether two samples means are different when variance are known and sample size is large. So if n is greater than or equal to 30, then only we can apply or go for the Z test. It is comparison of the means of two independent groups of sample taken from one population with known variance. So prior to going into the depth of it, just have a comparative view that we start with the statistical analysis and then we have a parametric and non-parametric test. And if we talk about the parametric, it can have certain attributes: testing number of success, testing number of proportion, testing difference of proportion. Whereas non-parametric test talks more about chi-square test, sign test, median test, rank sum test, which is Mann and Whitney U test, which we are going to consider in the forthcoming session. And as far as the parametric variables are concerned, I think when we have a small sample n is less than or equal to 30, that is we go for T test, and when the large sample is there and is greater than or equal to 30, we go for Z test, F test and ANOVA test. So we are going to talk more about all these tests in our forthcoming session. And as far as the large sample and small sample is concerned, we have a dedicated session which is a preceding session which much focus on how we are going to distinguish between small sample and large sample, and when we go for the small sample and when we go for the large sample. Because when we go for the small sample, I think there are chances that the inferential results could vary because the sample size is very less, and when you have a large sample, I think the cost is going to be involved and time is going to be consumed more. So keeping in mind all those things, I think this variables need to be taken care, and a small sample and large sample have got a great weightage, and that is the reason we have dedicated session which purely talks about how you are going to distinguish the small sample and large sample, and when you are going to take a small sample, when you are going to take a large sample. So parametric test is something which is very important, and when do you use which. So as far as the ANOVA test is concerned, which we are going to cover in our forthcoming session, which must focus on comparing the means or more than two samples, and chi-square test, testing goodness of fit to an assumed distribution. And as far as the F test is concerned, comparing variance of two samples. And as far as the T test is concerned, which we usually call the student T test, and elaborately we are going to talk more about the T test, comparing the means to a value or the means of two samples. So Z test is as T test but for large sample. So it's a kind of T test, but it is for the large sample, and as far as the T test is concerned, it is for the small sample. So non-parametric test, if we are going to talk about, we have goodness of fit test, test for independence and test for homogeneity. So chi-square goodness of fit test, as far as this test is concerned, test for independence, Fisher exact test is there, and test for homogeneity is chi-square test. So one sample Kolmogorov test is there, and chi-square test for independence, and two sample Smirnov is there. So Anderson-Darling test is a test which talks more about Mann-Whitney test, and then Kulper test is there, where we are going to see the Levene test for homogeneity, and this is the way. So when do we use Z test? So when samples are drawn at random, when samples are taken from population are independent, and when standard deviation is known. So when number of observation is large, that is n is greater than or equal to 30. So this is the thumb rule which we have to follow always as far as application of Z test is concerned. Do you know population standard? If we make a flow chart, yes or no is there. If yes is there, sample size could be greater than or equal to 30. If no is there, then we go for t-test. So since the sample size is less than 30, so we go for t-test, and since sample size is more than 30, we proceed with this test. So then again we make a flow chart and see yes or no, and yes is for test, Z test, and no is for t-test. So this is the way by which we are going to do it. So different hypothesis tests we have already talked about. We have talked about sample t-test, we have talked about sample t-test, then pair t-test, then test for equal variance, proportion test, proportion chi-square goodness of fit, and chi-square test for independence. All those comes under the ambit of parametric and assumes that data subscribe to a distribution, and as far as non-parametric is concerned, makes no assumption about the underlying distribution of the data, and simple sign test or man-Whitney test is there. So as far as hypothesis test is concerned, we have elaborately talked about theories of hypothesis. We have talked about the different hypothesis tests and why we are going to apply that hypothesis test. Either it could be the one-tail test or two-tail test, or the type 1 error, type 2 error. This we have already covered in our preceding session, and now we are emphasizing more on this different hypothesis test. So there is a difference between Z test and T test which we want to emphasize. If we talk about the Z test, we have already talked about data size need to be greater than 30, whereas T test data size is smaller than 30. So data point is not related or does not affect another data point. For example, in our illustration, both the control and the experimental group were independent from each other. And if we talk about t-test, which we are going to cover in our forthcoming session under the ambit of student t-test, data points might be related to each other where the behavior or value of one point may affect another. So as far as Z test is concerned, data is normally distributed. If data size is greater than 30, we can assume it is. And data is not normally distributed as far as T test is concerned. And data, if we talk about the data was randomly selection of the data is concerned, data was randomly selected from a broader population, and data was not randomly selected. So that is the reason, that is the reason we have distinguished between large sample and small sample. Z test always emphasize on the large sample, whereas T test emphasize more on the small sample. So sample size should be equal if possible, and sample size are not equally done. So that is the thing. So when to use Z test and T test? Use a Z test when you know the mean, that is mu of the population we are comparing, or sample 2 and the standard deviation sigma of the population we are comparing, or our sample 2. So we are going to use the t-test for dependent samples when subject tested are matched in some way, or use t-test for independent samples when subjects are not matched. So there are certain steps to follow for testing hypothesis. Set up the null hypothesis where HO is quoted by null hypothesis and theta is equals to theta 0 and one of the alternative hypothesis. So theta is unequal to 0 or H1 where theta is greater than theta 0, or H2 or alternate hypothesis 2 depending upon the problem. So select the problem. Proper alternative plays a significant role in decision making connection with testing of hypothesis. Choose the appropriate test statistics, mu and sampling distribution of mu under null hypothesis. In most cases, you follow the standard normal distribution under HO, and hence Z test can be recommended in such a case. So select alpha, the level of significance of the test, if it is not provided in the given problem. In most cases, we choose alpha equals to 0.05 and alpha equals to 0.01, which are known as 5% level of significance and 1% level of significance. So this is the step 3. And if we talk about step 4, define critical region based on the alternative hypothesis for testing. Theta is equal to theta 0, again both side alternative, and which is also known as null hypothesis. And H1, if we are talking about theta is unequal to theta 0, the critical region is given by mu 0 greater than or equals to mu alpha by 2 and mu 0 equals or less than mu 1 minus alpha by 2. So similarly, the critical region for right side alternative is given by mu 0 is greater than or equal to mu alpha, and the critical region for the left side is given by mu 0 less than or equals to mu 1 minus alpha. So obtain the value of mu 0 on the basis of the given sample observation. Reject null hypothesis if mu 0 falls on, otherwise accept null hypothesis. So draw your own conclusion in very simple language which should be understood even by layman. So there are assumptions of hypothesis testing. We must be aware of the assumption for the hypothesis test that we choose, and we must be cautious in choosing to proceed with the hypothesis test even though our data may not meet all of the assumptions. Note that in addition to these three assumptions, for many hypothesis tests including the z-test, the independent variable must be nominal. So the three assumption is dependent variable is measured on interval scale, and breaking the assumption, if you are going to talk about, usually okay if the data are not clearly nominal or ordinal. Participants are randomly selected, and okay if cautious about generalizing. So population distribution is approximately normal, okay if the sample includes at least 30 scores. So this is one of the assumptions of hypothesis testing, and participants are randomly selected, the distribution of the population is approximately normal. These hypothesis tests are those that produce fairly accurate results even when the data suggests that the population might not meet some of the assumptions. Parametric tests we have already discussed, and non-parametric tests we will not discuss here. So we are going to cover non-parametric tests in our coming session. So testing hypothesis, so identify the population, comparison distribution, inferential test and assumption, state the null and research hypothesis, determine characteristics of the comparison distribution, whether this is the whole population or a control group. We need to find the mean and some measures of spread variability. So if you're talking about the steps, these are into the 6 steps. Third step we have already talked about. The fourth step is determine critical values or cutoff. How extreme must our data be to reject the null, and test statistics value beyond which we will reject the null hypothesis. How far out must a score to be considered extreme. P-level, that is probability used to determine the critical value. Calculate the test statistics, that is Z statistics, make a decision. So statistically significant instruct us to reject the null hypothesis because the pattern in the data differs from what we would expect by chance alone. So test the assumption that the true mean hash of LED TV set in Indian home is at least 3. So state null hypothesis, where null hypothesis is quoted by HO and mu is greater than or equal to 3. State alternate hypothesis where mu is less than 3. Choose alpha is equal to 0.05. Choose n is equal to 100. Choose test, that is Z test or p value, and set up critical value z equals to minus 1.645. Collect data, 100 households surveyed. Compute test statistics which is equals to minus 2. Make statistical decision, reject null hypothesis. Express decision, the true mean of LED TV set is less than 3 in the Indian household. So this is what. So what is Z test? A Z test is a statistical test used to determine whether two population means are different when the variance are known and the sample size is large. The test statistics is assumed to have a normal distribution, and nuisance parameters such as standard deviation should be known in order for an accurate Z test to be performed. A Z statistics or Z score is a number representing how many standard deviations above or below the mean population a score derived from a Z test is. So a Z test is a statistical test to determine whether two or population means are different when the variance are known and the sample size is large. It can be used to test hypothesis in which the Z test follows a normal distribution. A Z statistics or Z score is a number representing the result from the Z test. Z tests are closely related to T tests, but T tests are best performed when an experiment has a small sample size. Also, T tests assume the standard deviation is unknown while Z tests assume it is known. Now we are going to talk about how Z tests work. Examples of tests that can be conducted as Z test include a one sample location test, a two sample location test, a paired difference test, and a maximum likelihood estimate. Z tests are closely related to T tests, but T tests are best performed when an experiment has a small sample size. Also, T tests assume the standard deviation is unknown while Z tests assume it is known. So if the standard deviation of the population is unknown, the assumption of the sample variance equaling the population variance is made. So the Z test is also a hypothesis test in which the Z statistics follow the normal distribution. The Z test is best used for a greater than 30 samples because under the central limit theorem, as the number of samples gets larger, the samples are considered to be approximately normally distributed. When conducting a Z test, the null and alternative hypothesis alpha and Z score should be stated. the test statistics should be calculated and the results and conclusion stated. So one sample Z test example, I think we have talked about, assume an investor wishes to test whether the average daily return of a stock is greater than 1%. A simple random sample of 50 returns is calculated and has an average of 2%. Assume the standard deviation of the return is 2.5%. Therefore, the null hypothesis is when the average of mean is equal to 3%. Conversely, the alternative hypothesis is whether the mean return is greater or less than 3%. Assume an alpha of 0.05% selected with a two-tailed test. I think one-tailed test and two-tailed test we have already covered in a preceding session, which was more focusing on the right and left. If you have a tail or at the right side, it could be the right tail, at the left side, it could be the left tail. Consequently, there is 0.025% of the sample in each tail and the alpha has a critical value of 1.96 or minus 1.96. So if the value of Z is greater than 1.96 or less than minus 1.96, the null hypothesis is rejected. The value of Z is calculated by subtracting the value of the average daily return selected for the test or 1% in the case from the observed average of the samples. Next, we are going to divide the resulting value by the standard deviation divided by the square root of the number of observed value. Therefore, the test statistics calculated to be 2.83 or 0.02 minus 0.01 divided by 0.025 divided by 50. And then we have the investor rejects the null hypothesis since Z is greater than 1.96 and concludes that the average daily return is greater than 1%. So Z test for a population proportion. Z test for a population proportion is a statistical test for population proportion, can be used when a binomial distribution is given that NP is greater than or equals to 5 and NQ is greater than or equal to 5. The test statistics is a sample proportion and the standardized test statistics is Z. So Z is equal to, quoted by this formula, which we have already talked about. So using a Z test for proportion P, state the claim mathematically and verbally, and this is the thing which is there. So there are some examples. Hypothesis test for proportion. So Zogby International claims that 45% of people in the United States supports making cigarette illegal with the next to 5 years. You decide to test this claim and ask the random sample of 200 people in the country when they support making cigarettes illegal with the next 5 to 10 years. Of the 200 people, 49% support this law. At alpha equals to 0.05 is there enough evidence to reject the claim. So verify that NP is greater than or equals to 5 and Q is greater than or equals to 5 and P is equal to 200 multiplied by 0.5 comes to 90 and Q is equal to 200 multiplied by 0.55 comes to 110. So solution is what? That when we are going to make a one-tail or two-tail test, I think we have plotted this in a thing, and then after calculation, the value of Z is coming 1.14 and decision is failed to reject null hypothesis at the 5% level of significance. There is not enough evidence to reject the claim that 45% of people in US support making cigarettes illegal within the next 5 to 10 years. So this is one of the example, and we have got some more example. The Pew Research Center claims that 55% of the US adults regularly watch their local television news. You decide to test this claim and ask a random sample of 425 adults in the country whether they regularly watch their local television news. Of the 425 adults, 255 respond yes. At alpha equals to 0.05, is there enough evidence to support the claim? So verify that NP is greater than or equals to 5 and Q is greater than or equals to 5. So NP equals to 425 multiplied by 0.55 is equal to 234 and Q is equal to 425 multiplied by 0.45 comes to 191. So if we plot this and in a figure, we find out that the right tail is coming, and the decision is that we have to reject null hypothesis at the 5% level of significance. There is enough evidence to support the claim that more than 55% of US adults regularly watch their local television news. So this is what exactly the model is. So what exactly, there are a lot of examples which we are going to talk, and so test of significance for population is there, and independent variable is very important because the word independent has different meaning in different branches of science. The statistical definition of independence differ from that in most areas of science, that is chemistry and physics. For example, where we talk about dependent variables, to a chemist, an independent variable might be pH, which the experiment can vary at will with reason, of course. So definition in physical science of an independent variable is one the experimenter can change when he or she wishes. This is quite different to the statistical definition, which we will discuss in succeeding text. So anyway, I think We have talked a lot about Z-test, and use of the Z-test to test population proportion is very important. When you have a sample size, when you large sample size, or rather we can say the sample size is more than 30. So we will have some more sessions in our coming days, which can much more focus on the different types of test. Either it could be the the F test, or the chi-square test, or the T test. Thank you very much. We will have some more thought-provoking sessions in coming days. Thank you.